let me talk about this one real quick, because this will be on the test next Friday. 1 week from today, you'll have a question that looks like this. And this will help you do another question as well. So anytime they're talking about angles between vectors, or if they're asking about parallel, perpendicular, or neither, you're going to use that formula that's cosine alpha equals the dot product over the magnitudes multiplied. All right, in this case, it just wanted to know, does that result tell you it's parallel, perpendicular, or neither? So here's the work that I had down. Let's take a picture. I did the dot product on top, which is multiplying your x values, and then adding that to your y values multiplied, which came out to negative 60. Then I found the magnitudes of each one. So magnitude is just square root of a squared plus b squared for both of them. And that results in square root of 20 times square root of 180. Top is negative 60. Bottom is square root of 3,600. But your calculator can do that. And you come up with negative 60 over 60, which equals negative 1, which automatically means it is parallel. If this chunk equals negative 1, 1, negative 1 or 1, it's parallel. If it equals 0, it is perpendicular. If it equals anything else, it is other. It is neither parallel nor perpendicular. Yes?
I don't understand how it could be 0.
It's not in this one.
It's not in this case.
Well, no, I know, but I don't understand. Yeah, 0 is on top. Like, now that we're talking...
What if you have 0 on top?
Well, like, I just realized on the homework on the question that... Can we do the problem?
What?
Can we do the problem? Can I tell you the...
Is it from last night's?
No, it's from like 2 nights ago.
Is this one that's perpendicular?
Yes.
Because the top would equal 0.
Yeah, but I don't understand how it's negative. It would be negative 2 times 6. Wait, no, I'm confusing myself.
Let me look at it real quick.
This one.
So it's that one. So the top would be negative 2 times 6, which gives you negative 12. Mm-hmm. And then plus 3 times 4, which is 12. So negative 12 plus 12 equals 0.
Plus.
This is why you should have all your work down. And I told you when you did this, you should go back and write your work down.
Yeah.
All right. This question can be asked differently. And you'd have to have a different answer. I'm going to finish up my train of thought. This could say, what is the angle between the two vectors? If it said, what is the angle between the two vectors, you'd have to take cosine inverse of both sides. In this case, you'd take cosine inverse of both sides, and you'd come up with 180 degrees. So be careful what the question's asking. All right, this question and what is the angle between vectors is basically the same question. It's just one takes one step further. Okay, Nick, did you still have a question?
No.
Okay. Questions from the homework then? Yes.
Number 33.
Number 33, did you do a different method? That'd be my...
No.
Did you come up with like 0.5?
Yes.
Yes. Okay, that's fine. That's fine. It's just, we use 2 different methods, so let's look at my method, and we'll look at your method. So on 33, I chose to do that method where I just rewrite the cosine 3.7 as negative 0.85. But look what happened here. I rounded. I rounded here, and then I multiplied that by 1/2, which got me out negative 0.43. What Luke probably did is he probably did, let me do it in red, he probably said, well, A equals 1/2 the cosine of 3.7, right?
That's exactly.
So that's going to come out a little bit different, just because of where we're rounding and stuff. Okay?
So it's still... okay.
Yeah.
How
So
did
I
you get-
assume that's what the problem was.
Yeah.
Because I had that question in all the classes, and I assume that was the problem. It was just the methods rounded at a different place.
Okay, how did you get negative 0.85?
I took the cosine of 3.7
I got...
radians. Oh, that might have been the big issue too, radians.
Oh,
There's no degree symbol. These are in radians.
Okay, there we go.
There's no degree symbols. It's radians. Be careful on that. I'll probably just leave in degrees on the test to not worry about that.
So much
Or I'll
better.
I'll specifically say make sure your calculator's in radian. I don't want you to get these wrong just because you're in the wrong calculator mode. But remember, if it doesn't have degrees, it's radians. All right, other questions? Yeah, Kate. 13. All right, 13. So 13. Whoa, what's happening out there? So 13 would be the point 8, 0, because that's 0 imaginaries, which means this point is 8, which means theta has to equal 0 degrees because it's not moving in this direction at all. There is no movement. It must be 0 degrees. The length of this is also 8. I showed the work down here, but realistically, it has to be 8. It has to be 8 because there's no triangle to form, so it equals 8. So it's just 8 times cosine 0 plus I times sine of 0.
You can tell it's 0 by drawing a picture.
And that's why I drew a picture. Yep. And that's why I always tell you to draw a picture, because that picture would show you that it's right here, which means it has no movement. Because theta is basically how far away from 0 is it, and it's right at 0. Okay, does that make sense?
Yep.
Good. Other questions? Yeah. 15. (15) is exactly the same as that one. You had to draw your picture. And if you drew your picture, that point is right here, which is 90 degrees. And the length, once again, is actually just square root of 3, because that's how high up it is. I did the work down here, but you could have also said, well, that must be square root of 3 because there's no triangles. And you just plug in. All right, other questions?
Wait, you said in every other class you had that question. Don't you only have 2?
So this would be the third one. No, I have 4 total. I have 4 total pre-calc classes.
What?
Okay, other questions on the homework real quick. So I want to make sure I get through all of them. Remember, do not, and I'm going to make this speech once again, do not just go online and copy the answers. You're just killing yourself. Honestly, that's what's happening, because even if you just copy the answers and say you're going to get back to it, you're never going to get back to it and figure out what I did. I would much rather mark you down as a 0 today and have you do the work over the weekend than me give you 10 points because you copied the answer key. Okay, I'd much rather you come here with tons of questions than no questions and then just wait till we take the test and not corrections and say, oh, I never really understood how to do that. And then I look at your work and it's just copied from my notes and you don't know what you did because you copied it from me. This is the time to ask questions and know how to do it. The time to learn this stuff is not when you're doing test corrections. That shouldn't be the time I have to sit down and show you how to do step by step these problems, okay? So make sure you're proactive, not reactive on these. All right, so we're getting into multiplying and dividing complex numbers. And the easiest way to multiply and divide complex numbers is to put it into trig form, surprisingly enough. Because when I multiply and divide complex numbers, you could think about it, it's like a plus bi times a plus or c plus c. Anyway, you have a whole bunch of i's floating around. You have I squareds, which become -1s. You have i's floating around that you have to combine. It turns very, very complicated very, very fast. But if they're in trig form, we can use these two identities to quickly multiply and divide them. So if we have 2 complex numbers in trig form, which we have up there, we have z sub 1 and z sub 2. Both are different complex numbers. The product is going to be, well, that's a product is yes.
Are you gonna have these formulas on our test?
I will not have any formulas on your test.
You can use our sheet, right?
No, you cannot use your sheet.
What?
All right, so we are going to have z sub 1 times z sub 2. That is going to equal r sub 1 times r sub 2. In other words, we're just going to multiply our two absolute values, magnitudes, or whatever our values are. Then we're going to open some parentheses. I'm going to use brackets just so I'm using two different. You can use parentheses. I don't really care. We're going to have r times cosine of theta sub 1 plus theta sub 2. And then it's going to be plus I times sine of theta sub 1 plus theta sub 2. So in short, to multiply two trig formed complex numbers, you just have to multiply your two r's and then add the two thetas that you have from each one. And just make sure you know the form r cosine, I sine. And it becomes pretty easy just to plug those numbers in. If you don't remember this thing, it's a really hard problem. They turn into really hard problems if you don't know this, especially with division. Division's really hard with complex numbers. Division is going to look very, very similar to the one we just did. It's z sub 1 divided by z sub 2. Instead of multiplication, we are going to divide our two r values. So it'll be r sub 1 divided by r sub 2. And then we're going to have cosine of theta sub 1. Does anyone want to take a guess at how I finish that?
Minus.
It is minus. It is minus. So see, your intuition will serve you well on this one. It is cosine theta sub 1 minus theta sub 2.
Minus I sine.
It's plus. It's still plus. Your intuition failed you there. But it's going to be I times sine of theta sub 1 minus theta sub 2.
You multiply it by r1 and divide it by r2.
Yes.
You looked like...
I had no idea what you meant by that question. Because in this one I do multiply my r's, and here I do divide by the r's. You just made a blanket statement that didn't... Because you said, so you divide by r2 and you multiply by r2. Isn't that what you said?
No, so you multiply times r1 and divide by r2. That makes sense, right?
Yes.
That's what I said.
Still a weird statement to make. All right, so that's it. They're both the exact same formula pretty much. So you just need to know one of them. And in fact, you barely have to know it. You just have to know the form r times cosine plus I times sine. Because when you multiply, it's just your two r's together, multiplied or divided. And then you just add or subtract your two thetas. So as long as you know that form, you should be able to do both of these. Let's do some examples. So this is, one of my complex numbers is 6 times cosine 2.4 plus I times sine of 2.4. This must be in radians because there are no degrees. My z sub 2 is 2 times cosine 1.8 plus I times sine of 1.8. So let's go ahead and do that multiplication. So multiplication tells me to multiply my r's. So that's that first number. So we're going to have 6 times 2. And that's going to be times our cosine of 2.4 plus 1.8. It's our two thetas added together. Plus I times sine of, once again, our two thetas added together is 2.4 plus 1.8. Close those parentheses off. And we're going to actually have 12 times cosine of 2.4 plus 1.8 is going to be 4.8. Oh, well, yeah, 4.2, yeah. Oof. My brain died for a second. I went with memorizing instead of actually doing the math in my head because it's really complicated. 2.4 plus 1.8 is 4.2 as well. That's it. Now, just stop here. Look at what the question asked. At any place in this question, did it say put in rectangular form or put in the form a plus bi? Does it say it in there? So don't. I wouldn't take any points off if you went further, but if you don't have to, why do it? For practice, sure. Yeah.
So what are the? Sorry.
Yes.
What are,
No, Nick raised his hand. You go first.
So, if
Well,
we
he
wanted
raised-
to solve that, would we do cosine 4.2 plus I, and then times sine 4.2, and then multiply the answer cosine 4.2 times 12?
Yes. Yep. It'd just be basically distributing this 12 to the cosine 4.2, but you'd go in your calculator, make sure it's in radian mode, and actually do that. All right.
sorry. So what exactly are the directions for this one? Like, like on the test, like how do we know to stop there?
If it doesn't say, put it in rectangular form, then you don't have to.
Okay.
It will specifically say, look at your homework real quick. Look at the very first question on the homework.
It's like this one.
What does it say right above it? It said your end answer needs to be in the form a plus bi. That's how you know to go further. But this one does not say it, so we're not going to. Okay, let's go ahead and do that division one. The division one is going to look very, very similar. My first one is 6, and we'll divide that by 2. And then instead of adding our thetas, we're going to subtract them. So we're going to have cosine of 2.4 minus 1.8 plus I times sine of 2.4 minus 1.8, close parenthesis. We're going to have 3 times cosine of 0.6 plus I times sine of 0.6. Once again, that must be in radians because there are no degrees. That was weird. It wouldn't let me close that off. Let's try it again. There we go.
I just realized I had a dream, and this is exactly what we were doing, and I used these exact colors.
Nice. All right. So those are finished and done because it says do not, it doesn't say anything about putting them in rectangular form. All right, questions on those two? All right, the next thing we're going to talk about are conjugates. For conjugates, let's think back at what a conjugate is, and usually we use conjugate for stuff like, say I had 2 plus square root of 2 on the bottom. I'd multiply my bottom of a fraction, I'd multiply it by 2 minus square root of 2, it's conjugate to get rid of that square root. Conjugate of imaginary numbers, on the other hand, are to get rid of the imaginary portion. That's where a conjugate is. When I have a complex conjugate, if it's in rectangular form, a plus bi, our conjugate is going to be a minus bi. And why it's going to be a minus bi is because hopefully when I multiply this, we're going to get rid of the imaginary portion. Let's check that on the bottom. So if I have a plus bi, and I multiply that by a minus bi, that is a difference of squares. So we're going to have a squared minus my bi squared. Well, bi squared is going to be b squared times I squared when I distribute that square. Yes, what is I squared? It's going to be negative 1. Yeah, because I is square root of negative 1. Square root of negative 1 times square root of negative 1 turns into negative 1. So this negative sign becomes a positive, and we're just going to have a squared plus b squared. So anytime you multiply an imaginary number by its conjugate, you're going to end up with a squared plus b squared. It's good to know because you can do the math, but it's always nice to be able to just jump straight to this, especially in this next one. This next one's a little bit different. It kind of seems like the conjugate would be just put a negative sign between the two, but it turns out that does not work, and we're not going to go through the process of why it doesn't work. Just believe me, it does not work. But the conjugate for this one is going to be r times, and it's going to seem weird at first, but it's going to be the cosine of negative theta plus I times the sine of negative theta. Negative theta. All right, why that works is we're not going to figure it out. We're just going to start this, and we'll finish it after the next problem. We're just going to write in the bottom, we're going to do the multiplication. We're going to do r times cosine theta minus I times sine theta. And we're going to go ahead and multiply that by the conjugate.
Why minus sine?
Oh, plus, sorry. R times cosine negative theta plus I times sine of negative theta. All right, that's my conjugate. And that's going to equal something. It's going to equal something really, really nice. But first we're going to figure out why, in case we get to the test and we don't remember it. Hopefully remember it, because this is going to make your life so much easier. Because look at the next problem on the next page. We're going to skip this for a second. We'll come back to it. But go to that next problem. I'm going to hold on a second. I'm going to come back to this slide. If you didn't get to finish this, I'll come back to that slide and you'll have time to finish it. All right, it says find the product of 2 times cosine pi over 3 plus I sine pi over 3 and its conjugate. So we're going to multiply this by its conjugate. What that's going to look like is we're going to have 2 times that cosine pi over 3 plus I times the sine of pi over 3, and we're going to multiply it by the conjugate. Well, the conjugate of this is just make your thetas negative. Or if they're negative, make them positive. But anyway. So we'll have cosine of negative pi over 3 plus I times sine of negative pi over 3. That is the conjugate. Conjugate is just take the opposite of whatever our theta is. So it becomes negative pi over 3. Now we're going to use that formula from the other side for when I'm multiplying stuff to say, well, this is just going to equal our r's times r, so it'd be 2 times 2, times our cosine of our alphas added together. So it'd be pi over 3 plus negative pi over 3. Then we're going to have plus I times sine of pi over 3 plus a negative pi over 3, close parentheses, and we're going to simplify. So that's going to equal 4 times cosine of 0 plus I times the sine of 0. And we're going to simplify this even further. We're going to put it in a plus bi form because we're going to see something if we do that. What's cosine of 0 equal?
0.
It does equals, no.
No, it equals
I was thinking sine, yes, it equals 1. Sine equals 0. So what's inside of here is really 1 plus 0 i's, which is just 1. So this whole thing just equals 4. But that 4 comes from the fact that we had 2 times 2. If this would have been 3 out here, it would have been 3 times 3. If it was 4, it'd be 4 times 4. So in fact, this 4 is really just our r times r, or r squared. So we really didn't have to do any of that work. Yes?
So if in the parentheses, what is being in the function of cosine or sine is the same, the answer is the product of the two numbers outside of the parentheses?
Say that one more time.
Okay. So if
What am I looking at here, I guess?
alright, first you're looking inside the parentheses. At the beginning. Right, at the top of the problem, they're both cosine and sine are both of the same number over there.
They have to be pi over 3 and pi over 3.
Yeah.
They have to be because it's both theta.
Oh right.
Yeah, they have to be. Whenever we put in trig form, they have to be the same. Otherwise, it's not the complex form,
Okay.
or the trig form of our complex number. Both those have to be theta.
Okay.
Yep, both those have to be the same. They're,
Okay.
you don't have to think if they're the same, then you can do this. They have to be the same in complex numbers.
Okay, yeah.
So you don't have to worry about it. But let's go back to that thing that we did. So a number, complex number, times its conjugate in trig form is just going to equal r squared. The beauty of this is I'm going to know who paid attention in class today and studied it, and I will know who didn't on the test, because there's going to be a question just like this on the test. People that study and paid attention in class are going to jump right to 4. They'll skip all of this work and just put it equals 4, because I don't need to do the work. It's just 2 times 2 is 4. The people that aren't paying attention or don't study are going to do all of this work and hopefully get it right at least.
You did all got it wrong.
And get it wrong? Yeah, when it was just
It was just-
2
wow.
times 2. And it just takes a little bit of studying, right? Just a little bit of r squared. Even the night before, you could just looked at it really quick. So study your notes. I find in these classes, the biggest thing people are lacking is actually going back in their notes and studying stuff. They treat reviews as if they're tests that they either know how to do it or they don't. Go back in your notes. That's why you have them. You should, the night before, at the very least, go through all of your notes to make sure you got the key concepts down. All right. Our next thing, it says, for z sub 1 equals negative 2 plus 2i square root of 3, and z sub 2 equals square root of 3 plus I, use trig, use trig form. I'm going to circle that. Are those two things in trig form? Not a trick question. Are those in trig form?
No.
No. No, they're not. So that's why I said before even looking at the rest of the problem, I'm going to put them in trig form. Because I'm reading their trig form. I don't even have trig form. Why would I even read what I have to do in trig form? I need to first put it in trig form. So the first thing we're going to do is put these in trig form. Just a reminder, the easy way to put things in trig form is to have our points laid out. So z sub 1 is going to be that negative 2 square root of 3. And I'm going to put it right down here. I just have it on the next slide. So I'm going to go ahead and paste that. All right. In order to put it in trig form, I need to have a theta and I need to have an r value. So our goal is to come up with our theta and our r value. I'm going to find my theta first. So that's theta. Let's find that first. In order to do that, it's probably a good idea to plot those points to make sure I know what I'm adding or subtracting 80 or 360. So we have negative 2 square root of 3. It doesn't matter how well you plot this. I'm going to put it somewhere up here. Right? Where my x value is negative 2. The height would be 2 square root of 3. But if you're getting good at this, you could probably skip a huge chunk of that. Because we just need to know that tangent of our alpha, I'm actually going to skip that part. I'm going to go right to alpha equals tan inverse of our y value, which is 2 square root of 3 over negative 2. Well, 2 divided by negative 2 is negative 1, so I'm actually looking for where tan inverse equals negative square root of 3. So a lot of you are going to plug this in your calculator, but on the unit circle, that would just be negative 60 degrees if you knew your unit circle. That just equals negative 60 degrees. But it's negative 60 degrees, so that's not actually my theta. My theta is going to be, since I'm right in quadrant 2, it's got to be somewhere between 90 and 180, so it's a little bit less than 180. So it's going to be that 180 minus the 60, which gives me the 120 degrees. That is my theta. So in fact, I probably shouldn't have circled that negative 60 because it really wasn't my answer. It just helped me get to my answer. All right, let's find our r. Our r is always going to be r equals the square root of our a. Our a is negative 2, so we'll have negative 2 squared plus 2 square root of 3 squared. That's going to equal, well, negative 2 squared is pretty easy. That's 4. Next one's a little more complicated. It's going to be 2 times 2, which is 4, times the square root of 3 squared, which is 3. So it's 4 times 3, which gives me 12. And that's going to equal 4 times 12 is 16. Square root of 16 is 4. That's my r. That's my theta. I can go right into my trig form. Is going to be 4 times cosine of 120 degrees plus I times sine of 120 degrees. Any questions on how I got that? Good, because you're doing the next one. So now we'll decide if you actually. So you should have came up with 2 times cosine of 30 plus I times sine of 30, and that comes from tan inverse of 1 over square root of 3 equaling 30 degrees, and my r being 2. This should go really quick. This should take maybe a minute, maybe 2. Because by now you should be able to go straight to tan inverse equals your y over x. Know what quadrant you're in. Know that since I'm in quadrant 1, that I'm actually finding my theta. My theta is my alpha. Alright, and then I'll put the answers to both of these. So if I'm multiplying those 2 together, you should have had 4 times 2, which would give you 8. Times cosine of, and you should have did 120 plus 30, which would give you 150. Plus, and the good thing is, once I have cosine of 150, sine must also be 150 degrees. Dividing, we should have had 4 divided by 2 would give me 2. And then we have cosine of 120 minus 30 would give you 90 degrees. Plus I times sine of 120 minus 30 also is 90 degrees. Both of our thetas have to be the exact same. So if you didn't get those, write down those answers and make sure you can get those. It's important that you do get those. I want you to quickly, I'll leave these up, but I want you to flip to your homework really quick. I'm going to have you circle something, and then I'm going to have you cross something out. If you look at the directions above 41, it says perform the indicated operations. It says write the answer in A plus BI form. So that means your answer needs to be in that A plus BI form. You will be in trig form, and you have to get back to A plus BI form. So make sure you circle that. You have to put it in A plus BI form. That is for 41, 43, 47, and 49. If you look above the directions of 51, it also says write the answer in the form A plus BI. Scratch that out. You will not write that in the form A plus BI. It's just too much work. They're already long problems. Just cross that part out. So then we'll have need to be in A plus BI or 41, 43, 47, 49. If you feel like the challenge, you can always go further. I don't have it on the answer key.
Wait. What are we crossing?
63, 65, 67 to 69, just deal with the conjugate. Either you're paying attention with that or not. Some of them can be really easy if you pay attention. If not, they might be really hard problems. All right, go ahead and get started. We're running a bit behind, so I will not check your homework.
Hi, I was just wondering is 4 the product and the conjugate? Like what's the conjugate?
This is the conjugate. This section right here.
Oh, but you still on the test we'll still have to do.
No, you don't have to do anything. If I say find the product of that and the conjugate, you can just put on 4.
But what's the conjugate?
This is the conjugate.
Oh, we would have to write that out.
Did I ask you to put the conjugate? If I said,
You said find the conjugate.
no, I said find the product of this and the conjugate. So if you look here, for the given complex number, determine its complex conjugate in string form. This you'd have to put conjugate down. This one asks find the product of the given complex number and the complex conjugate. If you want to, you can do all of these steps.
But I could just write down.
But you can just write down 9, yeah. Yeah. So I never specifically asked you to